Boise. The Standard Deviants present The Adventurous World of College Algebra. Look.
Oh my goodness, it's so ornate. What is it, Bonesy?
It's the ancient variable, the unknown quantity, the golden X of Algebra. It can mean everything, or it can mean nothing. Legend has it, whoever possesses it will attain the ultimate in algebra knowledge and know-how.
Don't you think that would look great in my Florida room?
Forget it, darling. It's a chick magnet. It'll look great over my fireplace.
Florida room.
Fireplace.
Florida room.
Careful. Be careful and stay here.
Baby mama wants an X. Come on.
Thank you, Dr. Bones.
You intellectual pygmy.
Yeah, I don't like your soup.
Oh, but Dr. Bones, it is you that are the pygmy without the X. Once again, you have shown there is more than one way to find the X. Until next time, Iowa Bones.
It's Idaho.
Idaho.
Hi, I'm Laura Hopewell, and welcome to the Adventurous World of Algebra Part 1. Over the next 90 minutes, we'll reveal to you the mysteries of this ancient and excruciating, yet exhilarating subject. We'll cram your brain with tons of functions, graphs, terms, algebraic properties, linear equations, polynomials, and all the different operations you can perform with these mathematical marvels.
Anytime you get lost in the program, just hit Title on your remote, and that'll bring you back to the main menu. From there, you've got lots of choices. You can view the program straight through, select which lesson you want to view, take a quick review, tune in to some helpful info, take the Algebra Adventure, a comprehensive final exam, or learn more about Cerebellum, the creators of this DVD program. What more could you ask for?
Let's see, a haircut or a change of socks maybe? But that's not important right now. What is important is that we dive right in. So let's get started right at the beginning.
Part 1. What is algebra? Section A. A little history. Algebra is a sort of universal arithmetic that replaces numbers with letters. Next to geometry, algebra is the oldest form of mathematical study. Records written in ancient Egyptian, Arabic, and Chinese show that all of these cultures explored aspects of algebra. Algebra was developed to solve practical problems dealing with astronomy, architecture, and property. Fortunately for us, the ancient Egyptians, Chinese, and Arabs did all the work in developing algebra, and we just have to follow their lead.
The English word algebra actually comes from the Arabic words algebra, meaning the coming together of parts.
One of the most common purposes for algebra is solving for x, or defining a variable. That is where you will spend most of your time in algebra and on your tests, solving for x. And that is where we will spend our time together. And that is why I have stolen it from Ohio Bones.
You can think of an algebra problem as a jigsaw puzzle that's missing one piece. But just because you're missing a piece doesn't mean you can't put the rest of the puzzle together. And once you fit the pieces that you do have together, you can see the size and shape of the missing piece. So you'll be able to recognize that piece when you see it. Finding that missing piece, the x variable, is the core of algebra.
So we see that the object of algebra and my own life's mission is the noble and unrelenting quest for the unknown variable, x. Well, class, it's time for me to go now. Put your homework on my desk.
Section B, Terminology.
The basic building block for all of college algebra is the function. A function is an algebraic statement that provides a link between two or more variables. It can be used to find the value of one of the variables if you know the values of the others. So, take the simple function y equals 2x. If you know x, you can find y.
For example, for the function y equals 2x, suppose that you know x equals 5. Then y equals 2 times 5, or 10. Since we know x equals 5, we can find y, which is 10.
If you know x, then you can find y. Well, I want to know y, so I must find that x.
This situation occurs anytime one variable appears by itself on one side of the equation. In y equals 3x plus 4, y is a function of x because y appears by itself. It's important that y is unadorned by any other symbols. It isn't y squared or 1 over y or the square root of y. It's just plain y. Whatever you compute using the other side of the equation just gives you the value of y. So in this way, a function is a codependent relationship between x's and y's. Without x, you can't get y. That's the idea of a function.
Yes, but you must remember the official meaning of function. A function is a very specific kind of relation in which each element of one set is paired with one and only one element of the second set.
You have to remember from basic algebra that a relation is any numerical expression relating one number or set of numbers to another.
There are basically two kinds of relations, equations and inequalities. Relations can be as simple as the equation 1 plus 3 equals 4, or the inequality 8 is greater than 5, where specific numbers are being related to each other. The arithmetic you learned or didn't learn in grade school explored specific number relations.
But algebra explores relations between non-specific numbers, or variables like x and y, that represent a whole set of possible numbers. Variable relations, expressions that contain variables like the equation 2x plus 3 equals 9y, look more like the kind of algebraic expression you've seen before, and will have seen way too much of by the time we're through with you. Okay, honey, open wide. Have some variable soup.
No more, no more. This smells rank. Anyway, when the specialist said a function is a specific kind of relation, he was really thinking of equations and inequalities. What kind? The kind that can be used to determine just one value for one of the variables. That is exactly what we saw before with y equals 3x plus 4. When you substitute a value for x, you can calculate just one value for y. So the very specific kind of relation that the specialist was talking about almost always boils down to an equation with one variable by itself on one side. And we say that one variable is a function of whatever other variables appear on the other side.
Okay, you've probably seen this before. It stands for function of x, but it gets repeated so often that to save time, it's shortened to f of x. Now, f of x is just another way of saying y in a function. We'll explain.
It works like this. Before, when we wrote y equals 3x plus 4, that expressed y as a function of x. Another way of writing this is y equals f of x equals 3x plus 4, or just f of x equals 3x plus 4. This is how you'll see functions represented most often. So it is called the standard form for expressing a function. Functions are easiest to recognize and deal with when they are in standard form, and most of algebra is concerned with putting functions that are not in standard form into standard form, so you'll need to be really familiar with this kind of relation.
Yes, but why stop with the letter f and f of x? We can also have g of x and h of x and p of x, and that still leaves all, 377 letters of the Martian alphabet.
Whoa! The specialist is getting a little carried away. Math specialists do like strange symbols, but I think we can leave the Martian alphabet for more advanced courses.
I don't find these humans funny at all.
In algebra, be prepared to see equations like these. Each of these examples defines a function of x, and we use different letters like f, g, and h to distinguish between different examples. These functions are read as f of x equals 2x plus 1. G of x equals x squared minus 3x plus 2, and h of x equals 2 to the x power, respectively. Remember, given an equation for a function, you can calculate the function as soon as you know a value for x. For g, for instance, if you know the x equals 5, you can immediately substitute x equals 5 into the equation. So g of 5 equals 5 squared minus 3 times 5 plus 2. That is 25 minus 15 plus 2, or 12.
If it seems like we're spending a lot of time on what is really just vocabulary, that is because algebra, like most math, is written in a very precise, extremely specific language of its own. So, just like with any foreign language, it's incredibly important to know the vocabulary of algebra.
Well, we're hot on the trail of this Viner Cross guy. Hey, boss, what do you make of this language?
Kids' clothing sizes?
Maybe it's movie ratings.
Anyway, you have to be familiar with some of the terminology we'll be using in order to discuss functions. If you already know this stuff, then don't get impatient. Just fast forward.
In most situations, the standard form can be considered in terms of terms.
Quick, Boise! Here come the terms!
When algebraic expressions are made up of parts that are added and subtracted, each part is called a term.
Duck!
Terms are always separated by plus or minus signs. For example, in the function f of x equals x squared minus 3x plus 2, x squared, negative 3x, and 2 are the three terms that make up this equation. Each term has two parts, a constant and a variable. Here's a hint. The constant is the number, which always has a constant value. The variable is the letter, which has a value that varies.
Hey, this is Herbie Hot coming at you from WFOFX with a new tune from the Peeping Terms. rockin'.
Constant is a number. It tends to stay constant. Ha! Variables are letters, and they tend to vary. Ha! 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 Ooh, I got a lot of math in me. Ha! Woo!
Each term has a variable x raised to a different power. X to the second power, or x squared, x to the first power, and x to the 0 power. The constant 2 is really 2 times x to the 0 power, but x to the 0 always equals 1. So it is never seen, but always there, kind of like air. The same thing applies to the term negative 3x. The x is to the power of 1. It isn't seen, but it is always there.
Hey, old man. Word on the beach says you are pretty good with identifying parts of a term.
Yes, I am, Illinois Bones.
It's Idaho.
Whatever. A function or expression containing only one term is called monomial. Mon ami.
I hate France.
But he really loves pasta.
What are those? Oh, these are examples of monomials. 2, 3x squared, and 5x to the 12th.
What about this one?
Oh, expressions with 2 terms are binomials. X squared plus 2, 4x to the 4th plus x squared, and 5x to the 12th plus 3x to the 7th.
And this one?
Oh, trinomials then are expressions with 3 terms. 8x cubed plus x squared plus 2, 4x to the 4th plus x squared plus 5, and 5x to the 12th plus 3x to the 7th plus x cubed.
I'm detecting a trend here. All right, Boise, let's go. Thank you.
Get out of here!
Don't hit him!
Sorry.
All of these expressions are called polynomials. Any expression or function containing one or more monomials, binomials, trinomials, or basically any other nomial is a polynomial. Now, sometimes a polynomial may appear in disguise.
This guy's a polynomial.
The expression 3x minus 2 times the quantity x plus 4 doesn't look like our earlier examples. It isn't made up of simple terms separated by a plus or minus sign. And it has parentheses. But as we will see, it can be put into a different form. If you multiply it out, 3x minus 2 times x plus 4 becomes 3x squared plus 10x minus 8. And that is recognizable as a polynomial. So the word polynomial refers to anything that appears in or can be put in the form of a monomial, binomial, trinomial, or any other nomial.
The highest exponent in any polynomial is called the degree or order of the polynomial.
This rule holds whenever you have a polynomial with a single variable on one side of an equation.
For example, the function f of x equals 8x to the third plus x squared plus 2 is a third-degree polynomial because the highest exponent in the equation is 3. And the function f of x equals 3x to the 7th plus 5x to the 12th plus x cubed is a 12th-order polynomial because the highest exponent in the equation is 12. Cool?
The constants that are multiplied by the x variables in each term are called the coefficients. In 3x squared, 3 is the coefficient of x squared. In negative 5x to the 7th, negative 5 is the coefficient of x to the 7th. And in 64x to the 5th, 64 is the coefficient of x to the 5th.
So, that covers the basic terminology that we use when discussing functions.
All right, let's move on!
Quiz 1.